All right, this video is going to walk you through the day 3 lesson on statistics. The very first thing we're going to do is review what we learned yesterday, which was dot plots and stem leaf plots, followed by the new things, which are histograms and box and whisker plots. So if we could get you to take out your worksheet right now, it looks like this. It has Timberwolves scores of the last 11 games. Well, what I'd like you to do is take your calculator, plug in 11 scores into your calculator, sort the data, and then make a dot plot and a stem leaf plot of your data. Once you've created those two graphs, we want you to analyze what you see and describe the SOCS of that data. Describe the shape of the graph. Is it symmetrical, uniform, skewed left, skewed right, or bimodal? Next, decide if there's any outlier values, yes or no. Do you see a dot or some score that's out away from the rest of the data all by itself? Yes or no. And then next, what is the median score, the C, or the middle score that you see of the Timberwolves scores? And lastly, what do the scores range from, listed off with a dash between both the minimum dash up to the largest maximum value. State those things, pause the video, and we'll see what you can do in the next few minutes. All right, as you started this question, I hope you got all of your numbers into your window right here. The way you got here was by pressing the stat key and then choosing edit. Once you chose edit, if there were things in here before, you hit the up arrow, select L1, hit clear, and then hit enter. That would clean out your entire list. But I typed all the scores in here first, and then if you want to sort your scores, you press stat. You choose this little option for sort A, option 2, and then you have to tell it what list to sort. Since you've typed it in the first column, you're going to press second 1, and then that creates the L1 icon on your calculator, and then eventually when you press enter, it just sorted all these scores now from least to greatest. Now you didn't have to do that on this one because there's so few scores, but I still want you to see how you sort data because it makes making these graphs a lot easier. So when I go back to stat and go back to edit, you'll notice all the scores can be now put on this number line here of values and then stacking up any repeats that you see, like you see right here. And the same thing goes for stem leaf plots. It's a lot easier to go right down the list of this list right here, building the 90s, the 100s, the 110s, and so on. But it's also important you include a key. The key in this question right here, the key, would be you saying that the number 93 is 9 bar 3. That's important to add to your stem and leaf plot also. Lastly, as you look at the shape of these graphs, it's not really easy to see a shape of this data here since it's so flat and laid out. There is a small little pimple right here, and you'll see that it looks like this. I would describe this, for the most part, as symmetrical. The same thing I would describe this graph right here. You could maybe say a little skewed left, but it's not really. It's pretty much the same shape on both sides as well. So we would call this symmetrical for this shape. Are there any dots way out by themselves? Kinda. So right now I'd say no, because when you see the stem leaf plot, there's no like space and then some numbers off by themselves. So I would say no for outliers. The center, since we have 11 data points, if you take 11 divided by 2, you get 5.5. Since we have an odd number, you round that 5.5 up to 6. So if you go to your calculator and go down to the 6th data value, look at the parentheses right there. That 6th data value is 115. So that should help you get that figured out as well. And lastly, the spread was 93 to 135 for your scores. That's the first part. That's what we learned yesterday. Now today we're going to learn about histograms. Histograms are the new graph we're going to work with here that takes quantitative data and makes it look like a bar graph. We take the data that we're given and we try to spread it out and make intervals that are equal in distance apart and get it into the number of bars we want to create. Now these bars we call classes. If I want to have homework for today, most of the homework problems are going to use 5 classes as opposed to the 4 classes that you see here. And then you try to make the intervals, in this case, count by 10s across. We'll have to figure out what we need to count by when it's other different amounts of data values. So let's look at the first example I have right here first. If I've got 11 as the starting number and 38 as the biggest number. So then what I have to make sure I do if I'm going to have this fit into 5 classes is that 5 has to go into both the smallest and the largest starting and stopping points of my intervals. So as I look at this problem right here, 11, since 5 does not round nicely into that, we're going to take the 5 and we're going to round it down to something that 5 can go into, which in this case would be 10. Then, that one on the right-hand side, 5 does not go into 38 also, so I need to round that up to something 5 can go into, and the next 5 that it can go into is 40. Now, as you try to figure out the intervals, I have to first of all figure out how far apart is it from 40 to 10. If I take 40 minus 10, I get 30. So if I take 30 and I want to divide that into 5 classes, then I will get the answer of 6. That 6 I get is what I need to count by. I want to count by 6s, okay? Now as I create this graph, I want the graph to start right here at 10, and then you're going to count by 6s. So if I start at 10, down this table of classes here that I'm going to create is going to be 10, then it goes by 6s, so that'd be 16, then 22, then 28, then 34, and then you'll notice the 40 would be going to 40 next, but 40 is not a part of these intervals. We always want our intervals to have a starting and stopping point, so we're going to make this thing stop at the one just short of the one below it. So if I have 16 below it, I need to stop at 15, and then pick up at 16, going to 21 here, 22 goes to 27, and then 28 goes to 33, and then 34 goes to 39. Not 40, because 40 is the one right below there. That would be if I kept going, but I'm not. So I stop at 39. That will come into play later. Do you notice how 40 is not part of the interval? Had that been a 40 right here, and you went from 10 to 40 still, that 40 would get left out because it doesn't fit in the intervals that you're given. So it's important that the right side always gets rounded up, but the left side, if 5 can go into it right away, it can stay the way it is. But this one was an 11, so it had to round down in this example. So what I want you to see then, as I go into the next part of this slideshow, you're going to notice that I have this example here that is a repeat of what I just mentioned. So just to recap what we did, we round the 11 down, and then we put the 38 up, and then that distance was 30. Dividing by 5 classes made it go by 6. All right, now let's try to go to the next one here. I got data that goes from 5 to 88. Now if I'm going from 5 to 88, like I said earlier, if 5 can go into the starting number here already, then we're going to leave it where it is. Just keep it the way it is. That's what we're going to start our interval from. But 5 does not go into 88, so I need to round that one up to a number that 5 can go into, which would be 90. So as you round your numbers down, or keep them if they're already a 5, and then round these up to the next 5, that distance between 90 and 5, if I take 90 minus 5, that's going to give you 85. And I'm going to split it up into 5 classes, so I need to divide that by 5, and the answer then will come out to be 17. I need to count by 17s in this next part that we're going to try here. Count by 17s. So that means when I start my table here, I want to go 5, and then 17 more than 5 would be 22. If I keep going, that would be 39, and so on. And I'll let you finish in filling in the table. But if it's an interval, like I said, you always stop one short of the row below, and that makes this one then be 21. This would be 38, and this would be, well, let's see what the rest of this looks like. If I go back to my slideshow here, that one's going to turn into 22 to 38, 39 to 55, and so on. So I hope you're starting to see that when you see an interval for your classes today, if you want 5 classes, you got to keep or round down the one on the left. So we kept that one, round it up, but you're always going to take, whether it's divisible by 5 or not, the one on the right has to always get rounded up in order to capture that last number. All right, so this example right here is an example of what I'm just trying to talk to you about right now. If I've got 20 as the smallest and I've got 45 as the largest, notice this. I want to keep the 20 the way it is, and I want then the 45 to go up one additional interval of 5 to 50. If you subtract 50 minus 20, you get 30. To go into 5 classes, you take 30 divided by 5, which means we'll be counting by 6. So then you start at 20, counting by 6s makes this red column right here. And then I want to stop one short, so that puts you at what you see here for the black values of the intervals where they need to stop. Now, as you've seen this now with numbers that 5 can go into, if it's on the left, you keep it. If it's not something 5 can go into, round it down. But the right side has to always get rounded up an additional multiple of 5 to capture the number 45 in this example. All right, now let's go to our Timberwolves numbers and see if you guys can figure that one out. All right, and notice that this smallest data value is 93, and the largest value of the scores was 35. So if we have a number at 35 and a number at 93, 5 does not go into 93, so I need to round that down to a 90. So 90 is what we're going to start at. And this 135, even though 5 can go into it, it needs to round up to 140. Now if I take 140 as the top and 90 as the bottom, subtracting those two numbers, you're going to take 140 minus 90, which is 50, divided by 5, and that's going to equal 10. That's why we're counting by tens. Okay, so we're going to count by tens, make that nice and big here, on the actual interval table. So that means we're going to start at 90, count by tens, so that means this goes to 100, this one goes to 110, this one goes to 120, this one goes to 130. Now you're going to finish off each interval by stopping one short of the one before it. So this goes to 99, this goes to 109, this goes to 119, this goes to 129, and this would have been a 140 down here, so this was going to stop at 139. Now as you build a histogram, since you said we start at 90, the origin of the graph also is going to start at 90 as well. And then we're going to count by tens like we said here. So that's 90, 100, 110, 120, 130, 140. Now if I'm going too fast, take time to pause the video and then catch up to me. All right, now what we have to do is build a frequency of these numbers. The stem leaf plot's pretty easy to look at. You'll notice in the 90s, I only have one number in the 90s. In the 100s, I've got two numbers, 103 and 107, so I have two there. I've got three in the one teens, whatever, so you got 3 times it happens in the teens. And then the 20s, this happens 3 times also at 121, 122, 123. And the 130s, it happens twice. This is the frequency of our values. Now, as you try to build the histogram, start the very top one as the highest number you saw here, so that's 3. Then create hash marks to accommodate the other ones that would fit below this, so I could have 2 and then 1. So I got 1 and 2. Try to space them out as best you can. I did it okay, I guess, but now we're going to try to build the histogram with the bars. So from 90 to 99, that happened one time, so we make a bar, and we want to label it just so there's no confusion that that is one frequency high. The next one is going to go from 100 to 110. That happened 2 times, so you can see that I'm going to make my bar go up to 2. As I go from 110 to 119, right here, this bar goes up to 3. And you can build your histogram with a 3 there. And then the next one also goes 3, so just continue that off to one more bar. And then the last one goes back down to 2. So just kind of do your best to put it where you think it should go for 2, and then label that as a 2. And again, if we talked about the shape of this data, it is what I would consider pretty symmetrical. You have it going up, and then it comes back down pretty steady. And that's also why you might say the data is symmetrical. And then now what we're moving on to now is trying to find the mean, the median, the mode, the minimum, maximum, and the range. So in this case right here, if we're going to find these values, it's going to happen really easy using this one var stats feature on your calculator. So what I need you to do first of all is pull out your calculator, press your stat key. You're going to notice that the calculate option is here also. Now I'm assuming you've already typed all your numbers into this stat edit window. Pause the video if you need to, if you haven't done that yet. But for right now, go to calculate, move the right arrow over so it goes to this. You'll notice the very first option is one var stats. Now it depends if your calculator is newer or older. This calculator is pretty new, so I get this little extra menu that shows up first. But if your calculator is older, it'll just say one var stats on your screen, and you just press enter one more time. But for the rest of you, just make sure it says L1 if you get a list like this. Make sure it says L1 and then nothing here, and then the word calculate. Keep pressing enter till you see the actual screen tell you some numbers. Now on my screen, it's going to say 116 with this little X and the bar over it. That X with the bar over it, that's the mean. So when I go over here to this, the mean is this little X symbol. I'm going to write that out here too on my paper so I don't forget this, that the X with the bar is the mean of the data, or the average, which in this case right here is 116.18. That just tells you that the average score of the Timberwolves games was 116.18 points. Now, if we're going to find the mean, that's the middle data value. Now, we did earlier count our way to the middle here, and we also did it right here. But if you scroll down on this one var stats window, keep pressing the down arrow, you'll notice that there's an option here for the median right here, which is 115 also. So that 115 that we found for the center now can be found a little faster with your one var stats of 115. So that's your median, the middle number at 115. And even when it's an even number of data, it'll still figure out that nice average number of your middle value. Now the mode is a tricky one. It is when you have numbers that repeat the most. Well, in this case right here, there's only one stack of numbers right here at 114. And that 114 was the time when that actually happened like this. So 114 is the mode. Now in the Olympics, if you have 2 people that finish with the same speed of, like, let's say swimming, they give 2 gold medals if they're the exact same time when they touch the wall. So in that case then, you would have 2 mode numbers instead if there were other stacks of 2 dots somewhere else also. But if there is no, in any of them, any kind of standout or sets of standouts, then there is not going to be any mode, and you'll just type D and E in your homework if that shows up in the case of that. Next, the minimum and the maximum. We can see it on the graph right here as 93 and 135, but it also shows up here as well. You'll see it says 93 for the minimum and 135 for the maximum. And then what did I say it was? 93 was the minimum and 135 was the max. Lastly, the range. The range is a distance. It's the distance from the minimum to the maximum. That distance from when you go from 93 up to 135, that's going to be 42. That's your distance from the minimum to the maximum. Okay? I should say min to max too. Min to max. All right, to finish our sheet here today, on the front side of this sheet at least, the variables. Let's talk about what the variables are. Variables are the measurements taken. Quickly pause the video, but what is the variables for this question? Hopefully you're thinking about what got assessed. That was the score. The score was the measurement that was taken. Now, where did that score come from? It didn't necessarily come from the Timberwolves. It came from each of the games. Those are what the scores were measured from, each game total. So the games are the individuals, not the people that play the game, but the games are the individuals. And since this set of data is all numerical, we're going to call it quantitative. Okay? Next, which graph shows the best distribution of the data? I think you could make an argument. I would argue that the histogram or the stem leaf plot are your choices, but I'll just say stem leaf just because I like the way this one is nice and tidy. But in this case here, you've now learned how to do all three graphs. We're going to pick up our fourth graph. All right, now we're ready to move on to our last part, which is box and whisker plots. What I need you to do first of all is just watch what we're talking about here with box and whisker plots. And the first part of box and whisker plots you need to understand is it's based off of percentiles. If you were scoring in the 80th percentile of something, would that be a good thing or not a good thing? Well, the 80th percentile, what that means is that you are at or better than 80% of the people in the assessment of whatever that is. That's pretty good if you scored in the 80th percentile. If you scored in the 50th percentile, that means you're pretty average, and half the people did worse than you, half the people did better than you. So we want to use the idea of percentiles is to show where do you fit ranking everybody in order from least to greatest. Where do you stand in line of all those people? Are you at the very top, the bottom, the middle? And we talk about percentiles in that way. So if we see the ACT test, for example, they're going to get a results page back describing your performance. If this person were to have scored a 21 on the ACT, the rankings came back to them and it tells that person that they scored and ranked in the 56th percentile. That means they did better than half the people that took the ACT. Is that bad or is that good? Well, that's not too bad. I mean, you got better than most of the people that took it, half of them. Or this person actually got a little over half the people. And then the state, within their own state, they actually ranked and did even better with the people within their own state. Now, as you're trying to prepare for your own ACT and you get your own practice test this spring, ideally, find out where your lowest areas are. There's an English section, math section, reading section. New to you this year and the writing, those are both optional. You can opt out of those if you wish. But the three that you do have to do for this year's ACT is English, math, and reading with an optional science section if you wish. This person did pretty low in the science section, so they would want to spend their time reviewing those things. And the reason why you want to do well in these, if you are considering a four-year school, is that if you do well on the ACT, you can earn scholarship money in favor of your good score that you get on the ACT. So by working on these areas over the summer, before you try to take it again as a junior, or if you are a junior, looking at maybe taking it again sometime in the summer, practice these areas that you're not as good at. In the Career Center, we do have places or things that you can work on these areas in more specific ways. So talk to Ms. Walrick if you're looking for help in that area. But more importantly, these are what we call percentiles, and they show you where you rank. This person did a really good job in the English section. But as you keep on going, we're going to talk about the 100th percentile. If you are in a ranking, you're part of the data. So remember, there's no such thing as the 100th percentile. Now, if we're talking about percentiles in the form of 0 to 100, we could also talk about quartiles. Quartiles are talking about fourths of the data. Are you in the first fourth, the second fourth, or the third fourth, and so on? But like I said, if you don't have a 100th percentile, there's no fourth quartile. Quartiles count by 25%, as you can see right here. So every quarter captures 25% of the data. Now, as we use these quartiles, we can build what's called a box and whisker plot. But before we talk about quartiles, or before we talk about box and whisker plots, we need to first of all look at the data here. If I asked you to find the middle number out of these 7 numbers right here, it's pretty easy to see that 4 is right smack in the middle. So you'd say 4 is the median. Now that 4 is the divider of what's left. So if I'm going to talk about quartiles, then of the 3 numbers to the left of the middle and 3 numbers to the right of the middle, then the middle of those numbers, 3 would be your Q1, and then 7 would be your Q3. Now these Q's represent the quartiles. It's the spot that's a number that is equal to or better than 1/4 of the data. This Q2, or the median, is a number that's equal to or better than half the data. This number 7 is equal to or better than 3/4 of the data. So that's what this is talking about when we talk about these quartiles. 1/4, half, and 3/4. Now, as we use these quartiles to help us build a number summary, we can then talk about this number summary here on the right-hand side. So if I'm going to refer to this number summary here, the minimum value is the first number, 1, not hard to see. Whoops, we'll do that later. But let's talk about the median first, I guess. The median of 8 numbers, there is no nice middle number. So that middle number between 3 and 5 is a 4. So if you average those 2 numbers by adding them together and dividing by 2, you can get the median number either with the calculator, 1var stats, or you can simply just look at it here in the picture. That's 4 is the middle. Then if I have that 4 splitting the 4 numbers to the left and 4 numbers to the right, they don't have a nice middle either. So 2.5 would be your quartile 1. And then on the right-hand side, what's the number halfway between 7 and 9? Well, that would be an 8. So as I fill in my 5-number summary, it's easy to eventually see visually if the numbers are right in front of you and a small number of data. But if you've noticed in your homework, we've had large numbers of data, and we want to use the 1var stats on our calculator to figure that out. So let's go now to our data on the actual box and whisker plot of the Timberwolves data. So draw this picture first, pause the video, make this in the back of your paper, and then we're going to start to fill in the data here in just a moment. So pause the video, and then, like I said, build this picture first. All right, now we're back, and what I want to talk to you is, you took your calculator, you have all the numbers now to fill this picture in. As you did the stat button and you went to calculate, and if you go to 1var stats, this 1var stats tells you what to do for this actual box and whisker graph you're going to be making today. So you go 1var stats, keep pressing enter, and eventually all the data shows up. Now as you have it on your screen, the numbers you care about are at the bottom of your screen. So scroll down, there are your 5 numbers right here. The minimum, the maximum, and so on. Now those middle 3 numbers are important to you. Those middle 3 numbers are going to always show up on your box and whisker plot. This right here is the box. So in this case right here, my Q1, as it mentions right here, is going to be at, what does it say? It says my Q1 is 107. So 107 is my Q1. And then my median is going to be at 115. And my other part of the box is 123. These are not negotiable, okay? You have to have those 3 numbers on the box. Now where it gets a little tricky is, oops, that's 123. And then what that means is the box and whisker plot essentially breaks the data up. When we say Q1, 1/4 of the data is equal to or less than 107. So 1/4 of the scores of the Minnesota scores were equal to or less than 107. 1/4 of the scores were between 107 and 115, because this makes up 25%. All of these values over here are 25%. This is 25%, and this is 25% of the data, okay? Sometimes the whiskers are all you have, sometimes you have outliers. We're going to talk about that in just a moment. Now, as you're building the rest, we have to decide, is 93 an outlier? That was one of the questions we asked on the front side of the sheet. There's a formula to help us figure that out. Now, this box that you see here between Q3 and Q1, we call that distance an inner quartile range. Inner, and I'll say IQR to abbreviate that, inner quartile range, and you find that by simply subtracting Q3 minus Q1. In this case right here, I would be taking 123, the Q3, and subtracting 107. That distance is going to equal, what did I say that comes out to? That comes out to be 16. So that distance of how wide the box is 16 for that width of the box. Now if you want to find out what an outlier cutoff is, we have to take this distance of how wide the box is and go 1.5 boxes to the right. Now I don't have enough paper to show us the scale, That's why I drew it like I did here. But we're going to take 1.5 of these and figure out when I take 1.5 of that times this. So if I take 16 times 1.5, what does that give us? I need to take 16 times 1.5 to find the upper cutoff. Well, here, let me do this first. Let's write down on your paper upper cutoff, and then write this down too if you can, please. It'll definitely help you for later. You're going to take the Q3, and we're going to add 1.5 of these boxes to the right. So you're going to go plus 1.5 times the IQR, like this. So if I were to do that with numbers, for this upper cutoff spot where things become outliers, I would take Q3 of 123, and I would add in 1.5 times that distance of how wide the box is, which is those subtracted, and it comes out to 16. Now when I take 123 plus this, which is going to come out to be 24, you get 123 plus 24, and that answer comes out to be 147. 147. So that's the upper cutoff, okay? Upper cutoff is 147. That means at 147, if I have any data values that are bigger than 147, we would call them an outlier. So if I go back to my scores on my calculator, under the stat edit window, do I have any scores larger than 147? And the answer is no. So that 135 you see here is going to not be an outlier. So we, in this case here, do not have an outlier, so we're going to say DNE, since this problem does not have any outliers. This, if I were making the box and whisker plot, this dot and line would not even show up in the picture. All you would see is a whisker. Now that whisker is the largest non-outlier, and that 135 score, the highest score we had, which is not an outlier, then becomes our whisker at 135. So since 135 was our largest number on the homework, you're going to question this 135. So you have all those scores and you have 135 as that last score. You have to decide, does your score go as a whisker or does it go as a dot as an outlier? Okay. Now let's go to our first score. The very first score you had in the list here was 93. We have to decide, is 93 an outlier? Here's how we do the lower cutoff. The lower cutoff, like this, is going to equal Q1, and we're going to subtract 1.5 of these boxes to the left to figure out where outliers become that on this side. So Q1's right there, and we're going to subtract off 1.5 times the IQR. So it's the exact same calculation. So we know that the Q1 is 107, so we're going to take 107 and subtract off 1.5 times 16, which is our interquartile range, the distance from Q1 to Q3, which is 16. All right, now that I've got that, I'm going to take 107, and I'm going to take that and subtract off, 107, subtract off, this is going to give me 24, again, the same number we had before, and I'm subtracting 24 from 107, and that answer comes out to be 83. All right, so that's my lower cutoff. So to try to decide what is the lower cutoff of my box and whisker plot, that's going to be 83. So I'll put an 83 right here. Now, if you think back to the scores, our first score was a 93, and you had a bunch of scores after that. So does this 93 become an outlier, or does it become the first non-outlier value of the whisker? Well, in this case right here, 93 is going to not be an outlier. It's not below 83, so we have no outlier on this side either. That does not exist. But for our actual whisker, we're going to have 93 be as our actual whisker number. Now notice that this cutoff value is not going to be something that's part of a box and whisker plot. It only helps us decide if our first number is an outlier or our last number is an outlier. If it is not, then it becomes the whisker. One last little technicality is that if you ever had, for example, a number in your data set at, let's just say this is 147 instead, then 147 would end up right on the line. If that ends up on the line, then 147 would actually be this number right here. You'd have this be a 147. But for the sake of our box and whisker plot that we're trying to create today, this is our picture. This would only be the actual graph itself. But for our homework, we're asking you, do we have outliers? And you're going to say D&E in this case, because there weren't any in the problem. Since you did 1.5 boxes to the right to get a cutoff at 47, 135 was not outside of that, so we said it's an actual whisker. The 93 that we had as our first number, our first lowest score, it then was not below 83, so it became the lower whisker of your box whisker plot. Now what we need to have you do is try to do the homework. You need to go to the modules page and try to figure out your own questions of making box whisker plots and things about this. But remember, this right here, the box represents the middle 50% of the data, where you'd hope most people are going to end up. When they end up in the upper quartile range right here, or this upper quartile here for the part above the third quartile, that's pretty special people. And then down here, these are also special people in some kind of other way, possibly. So great defense, great scoring team if you're scoring things up here. So that just lets you know how special some things are when you make box and whisker plots. Hope this information helps, and get going on the homework, and hope we got enough information to do the lesson today.